Hello everyone, hope you're doing well. Welcome back to the video. Basically, today's video is going to be more about a theoretical understanding rather than a practical hands-on building. Sorry about that, but just for me to continue down the road AI journey that I've been following along the Udemy course, this will give me a more understanding of a mix of balance with the theoretical and the hands-on aspects. So today is going to be about day six. Um, Understanding the different types of LLMs and why the LLMs are used in different frontier models. So let's get into it. I made some notes as well about the types of LLMs, the pros and cons, the characteristics, the use case as well. So in that way, we can just quickly go through it. You have an overview as well, and yeah. So day six. Today, exploring the different types of LLMs, their characteristics within the frontier model landscape. Understanding these distinctions is crucial for selecting the right model for a specific use case and applications. Now, what are the different types of LLMs? Well, the different types of LLMs are basically characterized based on their architecture, right? The architecture, their training approach, the data size, and of course the intended use case. So the number one that we have here is the base models. Sorry about that. Let me just quickly go up. Here it is. So the first one that we have are the base models, right? The foundation models. These are models that are pre-trained on huge amounts of data, text data, and these data is unlabeled. So therefore, this is an unsupervised base model without specific task optimization. They learn general language patterns, grammar facts, reasoning abilities. So the characteristic is that it's trained on diverse internet text data, books, articles, websites, code repositories. There's no specific tasks, alignment, or tailoring or fine tuning. So it's not optimized for following instructions or conversations. It's more completion focused and predicting the next sentence or word from the text from the context. So it's excels at continuing text rather than answering questions and requires fine tuning if you want to go into a more specific applications. So, for example, of this is ChatGPT 3, the base model of when it first came out in November 2022, at the end of that year. So. And then you have Mistral as a base. So here are the use cases for research and experimentation, custom fine tuning for specialized domains, text completion, generalization, building specialized models on top. So that's the first type of LLM. The second type of LLM is the instruction tuned models, right? This is where you fine tune those base models. So these models are fine tuned from base models specifically to follow human instructions, so the human prompts that it sends out in the system prompt chat, and then complete those tasks as requested. So the characteristics are that it's trained on instruction response pairs, so learn to understand and follow the command that the user gives in that prompt. And of course, the prompts that the user gives, it can either be a zero shot prompt where the LLM understands, or another like a few shot prompting. So it's better at task completion. It's more reliable for specific requests. It's still factual, so it still maintains the knowledge with the base training, and it may lack conversational polish, so it's not very optimized for a natural conversational flow dialogue, but still it's fine-tuned for it to give you like tasks automation, content generation to generate content like images, code generation, data extraction and summarization of data. So example is GPT 3.5 Turbo, and all the other models as well. Next up is chat models. So chat models are what we are known to or used to now with the chat model. So chat GPT, that's the chat model right there. So chat GPT means generative pre-trained model. Generative pre-trained model means that model is pre-trained, which is a base model, but is going to be using a chat model. So that chat model uses a reinforcement learning with the human feedback and aligned. So what that means is that chat models are basically they're instruction tuned models that are further refined through reinforcement learning from the human feedback. So the human feedback means the human is involved in the loop, and it kind of tells that model that the LLM, the base LLM, pre-trained LLM model to act as a chat model by having the reinforcement learning in place. So to have the natural conversations to align with the human preference. Therefore, the human feedback is there. So its conversational abilities excels at multi-turn dialogues that the human will have. It's more aligned to be helpful, harmless, and honest, context aware, safety guardrails, personality and tone. So more natural, engaging responses than the ChatGPT is, as we know. So ChatGPT 4, Claude 3, Gemini, ChatGPT, Llama 3.1. And these are use cases: customer support chatbots, virtual assistants, educational tutoring, interactive applications, personal productivity tools. Next, on number four is the specialized domain specific models. These are fine tuned or even more specialized models where nowadays, businesses and startups are using those LLM models as an API wrapper. So they're wrapping that model, the base model as an API wrapper, and then they're fine tuning it either through reinforcement learning with human feedback or another way of fine tuning it to perform specific tasks. So fine tuned models are trained specifically for particular domains, industries, or tasks. For example, for lawyers, for education, for code. So domain expertise, deep expertise in specific fields, optimizing vocabulary, better understanding of technical terms, task specific performance, outperform general models in their domain, smaller size possible. They can be more efficient for specialized tasks. So, for example, we have code models like Code Llama, a Star Code, Claude Code. These are the use cases for code example. Next is the medical models. So for medical, you have BioGPT. These are trained. These are like fine tuned and trained on the medical industry. Legal models, so like LexGPT, LegalBert for legal part. Like you have the financial models for finance. The AI are fine tuned. So use cases for code generation, debugging, medical diagnosis, legal document analysis, financial analysis, prediction, scientific research. Next up on the list is the multimodal models. So there's LLMs. These are the definitions that can process and generate multiple types of data, so including text, images, and audios and videos. So basically, it's like a image to text or text to image model generation that we have. For example, you have Sora 2 by OpenAI. You have Stable Diffusion. You have the Google Gemini VO3. That's one. So these characteristics is multiple input and output image types, so handle various data formats that the user sends, uploads, cross-modal understanding. It can also understand or relate the information across modalities. So if you send an image to that model and ask it to describe the image, it will be able to do it. Image description, so a visual question and answering, text to image, larger model size, so it's going to be more parameters to handle the different modalities and the architecture as well. And the use case for image analysis and description, visual question and answering, document understanding with images, creative content generation, accessibility tools. So, and then there's two more types as well that I'll also tell you more about it. So, let's say LLM number six, for example, is the uh, so we talked about chat models, we talked about specialized, multimodal. Specialized models is two times repeated, instruction tuned. So we have another one that is like an AI agent, which is from this article that I've kind of read and summarized it from. So let me just show you what is. So this is chapter number seven. Let me go chapter number six. LLM number six is the hybrid models. So hybrid models are basically integrating diverse capabilities. It basically hybrid concept of hybrid models is a term to apply different models into one. So reasoning models, multimodal models. So let me just go into the characteristics, give you an understanding. You guys can read more about it later, how it works, overview about it. But basically, hybrid models represent more a move towards more adaptive and efficient AI. So it's basically dynamically allocating the computational resources, selecting a more appropriate processing strategies based on the task at hand, and they promise to combine a more breadth of knowledge from those large language models with also the specialized capabilities. So therefore, that's a hybrid that it has in store. And the last but not least is an AI agents for in-depth investigation. So you know the deep research part option in the OpenAI Pro version, where you choose a deep research and you have an AI agent. So basically, that kind of gives you a more planning, task oriented agent work. So these shift towards more autonomous AI designed specifically to conduct complex multi-step research tasks by leveraging the LLMs, web browsing, tool use, and iterative refinement. So OpenAI's deep research agent, powered by the version of their O3 model, is a prime example in this category. And this is just more in-depth review and reading that you can kind of look at. The core functionalities about query, understanding, and planning, information gathering, tool use, analysis, and synthesis, iterative refinement. It goes to iterate and refine that process again and again, as you can see here, until it gets to the end goal. And then report generation gives you the answers and findings and structured report about what it's able to give you as well at the end. The characteristics that distinguish the deep research agents is that it's autonomy and iteration, extensive tool use. It uses a tool for browsing, for calculation, data analysis, or code execution. Focus on synthesis. The primary goal is not just information retrieval, but also the deep analysis and to synthesize across multiple sources to gather it as well and put it into a structured format. So for you to have your understanding as well. So this is the deep research agents, the type of LLMs as well. Potential applications are for professionals in generating market reports, comparative analysis, policy summaries, researchers and students for literature reviews, gathering data from diverse online sources, for consumers, and journalists and analysts for background research and multi-source insight generation. So you can just cross-check if you have other policies or whatever sources you want to analyze. This is where you can use AI agents for that deep research. Um, and yeah, I think that's mainly it from what I've understood. The types of LLMs are available. But one thing I can say is that an LLM, a large language model, is like a car that everyone has, basically. Now, the type of car that everyone has, that depends on the engine, of course, and the design of the car. You know, the application of that car, it depends, right? You can have different types of car: sports car, a normal regular car, or a race car. So that what LLMs are essentially. You can have different types of LLMs, the different applications for it, and their intended use, purpose of use, and also the size of the engine in the car. Also, it's like the size of an LLM, right? So how big the parameters are that it was trained on the data set, right? For that able to show its performance and efficiency, and how well it's able to utilize the resources that the LLMs use, which are uh, the the resource like electricity cost and also the water, so for cooling down the GPUs. So that is also equivalent for how well the engine uses the oil, petrol, for its performance running. So that's what the LLM kind of is. For me to give an analogy and to explain to a 5 to 10 year old, that is the type of a car that everyone has, but different type of car is a different type of LLM based on its applications and purpose of use. And of course, the LLM can be based on its size, based on the data set that it was trained on, and then it uh, can also be like applied to different use cases as mentioned. So that's mainly what I can kind of gather around and explain. So that was it for today's video. Sorry if it went too long, but let me know if anything else I missed out on or did not explain properly. Please put in the comments down below. And yeah, I'm still reading about it, understanding more about it. LLMs, like gathering, making a mind map for me to then understand and remember exactly what each LLM serves and models. So yeah, that's it for today. Thank you so much for your time. Take care. Stay safe. Bye bye.